Gemini 3.6 outputs 280 tokens per second. That's 3 times faster than Grok 4.5's best case of 90. If you're running a high-volume API at scale, that speed gap alone could flip your entire infrastructure decision. Both models dropped recently and everyone's asking which one actually holds up, so I went through every published benchmark, pricing page, and community speed test I could find, comparing Grok 4.5 versus Gemini 3.6 across 5 real tests. 12 sources, all cited, all checked. Now, the faster model isn't always the cheaper one, and the cheaper one on input flips to the pricier one on output. So if you're budgeting API costs right now, stick around because the pricing test is where things get genuinely weird. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. I went through the published data on both models, and I'm going to give you the straight read on where each one wins and where the numbers just don't add up. Okay, so who is this actually for? If you're running API calls at any real volume, like tens of millions of tokens a month, picking the wrong model is a budget problem, and a solo dev or small team can easily burn an extra few $100s a month just by defaulting to the wrong one. Test 1 is speed and latency. You've probably heard both models are fast, but 280 tokens per second versus 54 to 90 is not even close. And if your app needs real-time streaming like a chat interface or a live code assistant, waiting 8 to 14 seconds just to get the first token back is going to feel broken to your users. So what I looked at, Gemini 3.6 clocks in at 280 tokens per second from its official spec, and Grok 4.5 sits at 54 to 90 tokens per second from independent measurements. What surprised me is Grok's time to first token is 8 to 14 seconds, and I couldn't track down a figure for Gemini's at all, so that part of the comparison stays open. Gemini 3.6 takes this one, and it's not close. I was expecting a tighter race given how much XAI has been pushing Grok's performance story, but 280 versus 90 tokens per second is a gap you can't talk your way around, and that puts Gemini 3.6 up 1-0. Test 2 is reasoning accuracy. A solo dev shipping a production feature on a deadline needs to know. When this model writes code to fix a bug, does it actually fix it? A 6-point gap on SWE Bench Pro, which is 64.7% versus 58.7%, sounds small until you're debugging the failures at 11 p.m. on a Friday. Okay, so what I found, across Deep SWE 1.1, Terminal Bench 2.1, and SWE Bench Pro, Grok 4.5 leads on all three. But this is a big caveat you want to keep in mind. Grok's numbers are vendor claimed and Gemini's are from a community blog, not an independent lab, so these are directional, not definitive. No winner here. The data sources aren't apples to apples, so I can't call it, and that's one tie on the board. Score stays Gemini 3.61, Grok 4.50, with one tied, and you really want to run your own code tasks before trusting either set of numbers. Test 3 is pricing per million tokens. At 50 million output tokens a month, the difference between $6 and $7.50 per million is a real line item, and that's a $75 swing every single month, just on output that flips depending on whether your workload is input heavy or output heavy. So when I looked at the pricing pages, Gemini 3.6 is cheaper on input at $1.50 versus 2 points or euros per million, and way cheaper on cached input at 0.15 versus 0.50. But Grok 4.5 is actually cheaper on output at 6 euros versus 7.50 per million, which makes it a genuine split depending on your use case. Pricing is a tie. I was expecting one model to just be cheaper across the board, but the structure is genuinely split. Gemini wins on input and caching, Grok wins on output, and neither one dominates, so that's 2 ties now and the score stays. Gemini 3.61, Grok 4.50. 2 tests left, and this is where the context window gap gets genuinely hard to ignore. So if you're working with large documents or big codebases, the next test is probably the one that decides your pick. And the last test has a data problem that I think you need to know about before you trust either model with factual queries. Test 4 is context window, and the number itself is pretty wild. 1 million tokens versus 500,000. If you're trying to feed an entire codebase or a long legal document into a single prompt and Grok 4.5 hits its 500K ceiling, you're splitting the job, re-engineering your pipeline, and probably paying more per call to stitch it back together. What I found here is pretty clear-cut. Gemini 3.6 supports a full 1 million token context window, and Grok 4.5 maxes at 500,000. Gemini also caps output at 65,536 tokens from a published spec, but I couldn't find an output cap for Grok 4.5 anywhere. So that part stays unresolved, though the input context gap is real and verified. Gemini 3.6 wins context window, full stop. Double the input capacity, and it's a verified spec, not a vendor claim, which brings the score to Gemini 3.62, Grok 4.50 with 2 ties, and for anyone doing long document work, that gap is just too big to work around. Test 5 is factual accuracy. You've probably heard that hallucinations are a problem with newer models, and this is the test where that concern is most real. Because if your workflow involves pulling specific facts, dates, or technical specs, and the model just makes things up, you're not saving time. You're creating cleanup work. So what I found here is pretty thin. One community report flags Grok 4.5 as having a high hallucination rate, but it's a single source and I couldn't verify it independently. And for Gemini 3.6, I came up empty on any hallucination figure at all. So this dimension is kind of a blind spot for both models right now. No winner on factual accuracy either, and I can't score it fairly. So that's 3 ties total, and the final tally stays Gemini 3.62, Grok 4.50. Take the Grok hallucination flag as a reason to run your own tests before trusting it on anything factual. Alright, so here's where Grok 4.5 has a real edge. Output tokens cost $6 per million versus $7.50 for Gemini 3.6, which is a 20% savings on generation-heavy tasks. And on coding benchmarks, Grok's vendor-claimed SWE Bench Pro score is 64.7% versus 58.7%. So if code quality is your priority, it's worth testing. Now, here's where Gemini 3.6 is just straight up better. It's 3 to 5 times faster at 280 tokens per second. It has double the context window at 1 million tokens. It's cheaper on input at $1.50 versus 2.0 per million. And its cached input price is 10 times cheaper at 0.15 versus $0.50, which is huge if you reuse prompts a lot. So the honest call, Gemini 3.6 wins 2-0 on the verified tests, and that gap is real. If you need speed and a large context window, Gemini 3.6 is the pick, 3 times faster with double the context. If your workload is output heavy and you want to save 20% per million tokens, Grok 4.5 makes sense, so pick based on the job, not the brand. I ran Gemini 3.6 against Claude Sonnet 4 next, and the context window advantage completely flips when you look at output quality on long-form writing tasks. And the price gap there is way more interesting than what we saw here.